So now we're going to talk about when you multiply radicals. So the first example, I'm going to use the distributive property. Notice there's no radical with the 3. You cannot multiply an outside number, like the 3, with an inside with a radicand. So you simply take 3 times radical 7. That's how you multiply those together. Minus, you take your 3 times a radical 6. Looking at your answer, these radicands are not the same, so there's your answer right there. Moving on to having a radical outside. Radicands get multiplied together. There's a 1 outside, but we don't use the number 1. So 5 times 10 is 50. Again, I'm using the distributive property. The 5 can only go with the inside, the radicand. So I have 2 outside, and then 5 times 3 is 15. Now looking, my radicands are not the same. However, 50, there is a perfect square that will go into 50, which is 25. Think quarters and you'll get it. So 50 breaks down to 5 radical 2 minus 2 radical 15. Radical 15 will not break down anymore. So here's your answer for an example like that. Now, remember, you can use box method or FOIL method when you're doing this. Don't panic, just take your time. So setting up the box method, I've got a radical 6. And I've got a 4 radical 5. So these numbers are good. Now I'm going to take input on the side. I've got a 4 radical 3. And I've got a negative radical 10. So just like you did with regular numbers, you're going to do it with your radicals. So I have a 4 radical 3 times radical 6. Nothing can be multiplied with the 4. 3 times 6 is 18. Now I'm taking my 4 times my 4. I have outside numbers I have to multiply together. And I'm taking my 3 radicand 3 times my radicand 5 and get 15. Moving right along, I have a radicand of 10 and of 6. Keep my negative, so I get negative radical 60. And then my final, I'm taking a negative times a 4, a negative 1 times a 4 is a negative 4. Radicand of 10 times 5 is 50. So right off the bat, none of these will combine, so I'm going to go ahead and rewrite these numbers together here. So 4 radical 18 plus 16 radical 15 minus radical 60 minus 4 radical 50. And these all came from the box. So then you have to do more algebra because you're thinking some of these radicands will, I know you are, you're thinking this, some of these radicands will simplify. 18, a perfect square, goes in of 9, and I'm left with a 2. The square root of 9 is 3, radical 2. Got a number outside and a number outside. Multiply them together. 4 times 3 is 12, radical 2. So now I'm going to bring down my plus and look at the radicand 15. There is not a perfect square. 4 or 9 will not go into that. So that is already simplified, so I'm just going to bring it down with my other number. Looking at 60, and I haven't worked this one out, so give me a second. All right, so 60 will break down to 4 and 15. So the radical 4, radical 15. The square root of 4 is 2. So I've got 2 radical 15. Now remember to bring your sign down. So this is a minus 2 radical 15. Let's kind of give me some space here. I'm going to draw a line to get a little bit of space there so you can see. So then I have a minus, bringing it down from here, got a minus, and my 50 will break down to 25 and 2. The square root of 25 is 5, and then I have a radical 2. I've got numbers outside, so I multiply 4 times 5, which is 20, keeping my radical 2. Now I'm looking for any like terms, like radicands. Got a 2 here and a radicand of 2 here. So I'm going to combine 12 radical 2's, take away 20 radical 2's. So 12 minus 20 is a negative 8 radical 2. So that's an 8. Okay. Then I continue on and look to see if I can find anything else. I've got a 15 radicand and a 15 radicand. So I have 16 15 radicals, and then I've got 2 of them. So 16 take away 2 is a positive 14, radical 15. Cannot combine any further. There is your answer. For those of you who like to make mathematics perfect, we would put the 14 radical 15 and we would put the negative sign behind it to make it look more pretty. So either one of these I will take as your answer.